YouTube. In this video we're going to do the quick graphs of sine, cosine, and tangent functions. And basically I'm putting this video up there because I'll be very honest with you. We can graph sine, cosine, and tangent, or at least y equals sine of x, which will be the first one we take a look at here. Y equals sine of x. We can graph this. We can graph y equals cosine of x and y equals tangent of x. Simply by making a table of x and y values and plugging them in. However, I've made videos now on sine of x, cosine of x, and tangent of x that are very rigorous and very in-depth in why they look the way they do. And to be very honest with you, all I need at least my students to know how to do is make a quick graph of each of these basic parent functions and just memorize what they look like, how to make them. Okay, so let's go ahead and start with sine of x. Okay, so sine of x, basically, here's what you would need to know about sine of x. First of all, we need to acknowledge that its period is 2 pi. That is, it's going to take it 2 pi worth of rotation to basically roll back around upon the same y values again. So if on the unit circle, sine values are the y values, if I were to rotate 2 pi's worth of rotation or 360 degrees worth of rotation, you would see that the y values assume all of these values, the sine values, go back around and end up at 0 again. So if we were to rotate more than 2 pi, it would just basically repeat itself. So we only need to graph 2 pi's worth of this because otherwise it's just repeating itself anyways. So its period is 2 pi. So the basic graph of sine of x is you would draw this in here. We say that this graph has an amplitude of 1. Okay, essentially, and in future videos we're going to look at the next video here. It has to do with this number we're taking times sine of x, but it has an amplitude of 1, which means it's going to go 1 above and 1 below the x-axis. So the quick graph of this, here's how you do it. Basically, we know it starts at 0, it goes out to 2 pi, and that's how long it takes it to do one cycle. We're going to take this 0 to 2 pi period, we're going to split it in half, we'll call this pi, and then we'll take those halves and we'll quarter those. So basically, on every quick graph, all you need is the entire period. We're going to split it in half, split those halves in half, and then memorize this. The essential basic sign of graph starts at 0, starts on the ground, a fourth of the way through its period, so at pi halves here, it's up in the air at positive 1. Half of the way through its period, it comes back down to what I'll call the ground level there. 3/4 of the way through its period, it's down at negative 1, and then all the way through its period, it's back up at 0. This is the basic sine graph. This is the graph that you need to just memorize. How did I draw this again? Again, all I did was start by putting the period on here, splitting it in half, and then splitting those halves in half, and then just knowing that my sine graph goes ground, up, ground, down, ground. Okay, so here's our basic sine graph. So how would one necessarily draw the graph of cosine? Again, what we want to acknowledge is that cosine has a period of 2 pi. What does this mean? It means that if we look at our unit circle, if the cosine values are the x values, then we would see that at a 0-degree angle, cosine of 0 would be 1. And as we go around this, okay, so we get radical 2 over 2, 1/2, 0, negative 1/2, negative radical 2 over 2, negative radical 3 over 2, negative 1, goes down to negative 1, and then you look at the x values, they start creeping their way back around to 1 again. That is, you would have to plug in 2 pi's worth of rotation to end up where you started, which was at an x value of 1, and then it's just going to repeat itself as you keep rotating around this circle. So that being said, when we make this graph, we say, okay, so here's our y-axis, here's our theta or angle axis, we're just going to call it x. So we have, okay, so we have x, y, the graph of y equals cosine of x, we say has an amplitude of 1. Okay, 1, we'll determine this in the next video by knowing that this value up front was a 1. But essentially, we'll put on the period. So we say starts at 0, goes out to 2 pi. Here's our 2 pi. We say we'll split this in half. Half of 2 pi is pi. We'll split those halves in half. Those are pi halves and 3 pi halves respectively, but we're just not going to label them. All we need to do is split the entire period into fourths or quarters. So now, what does cosine look like? Now, cosine, again, we can cheat and look at the unit circle here, but it starts at 1. Okay, so at 1, at 0, when the angle is 0, we say the cosine value is up at 1. So it starts up in the air, okay? A fourth of the way through its period or its cycle, it's down at the ground level. That is, at pi halves are 90 degrees, the cosine value is 0. At 180 degrees, the cosine value or the x value is negative 1. So at pi, we're down here at negative 1. Sorry to scribble over my pi there, pi. Okay. And then it goes back up to the ground level, and then it goes back up into the air. You just know this. You just memorize the fact that cosine starts up, goes down a fourth of the way through to the ground level, half the way through its period, it's down to negative 1, back up to the ground level 3/4 of the way through its period, and then at the full period, it goes back up to 1. So this is one cycle of of cosine. Okay, so tangent. All right, well, tangent, here's what we want to acknowledge. Tangent actually has a period of just pi. It is the only graph besides its reciprocal, which is cotangent, that has a period of pi. For the sake of this example, I'm still going to sketch this 0 out to 2 pi, but we'd say really essentially, we'd say, all right, 2 pi, we'll split this in half, this is pi. Okay, so since its original period is actually pi, what I'm going to do is I'm going to split this out to pi in half, and then I'll tell you why I put 2 pi on here in a minute, but half of that would be pi halves, okay, and then we'll quarter these. So again, I've got my graph of tangent, and so here's what I'm going to tell you. Essentially what I need everybody to know is that when you plug in 0, tangent of 0, remember tangent of an angle is equal to sine of an angle over the cosine of an angle. And so we say sine of 0 was at a height of 0, and cosine of 0 was at a height of 1. So 0 over 1, you get 0. But here's all I'm saying. You just need to memorize that tangent starts off at 0. A fourth of the way. Here we go with 1 and negative 1 again. A fourth of the way through its period, it's up here at 1. Okay, it just is. It looks like this. Okay, so at pi halves, what do I know about pi halves? Well, pi halves, that would have been like here on my sine graph, if you look over here on the left again. Pi halves, sine was at a height of 1. So, you know, for tangent, we would get 1 over. At pi halves down on my cosine graph, however, we were at a height of 0. So 1 over 0, what do you know about 1 over 0? It is undefined. So tangent, just memorize this about the tangent graph. At pi halves, okay, and then since its period is pi, okay, so if we were to now split this in half and quarter those, and go out 1 pi past this, so pi halves plus pi would be 3 pi halves. It's just going to repeat the fact that it's undefined again, and it's going to repeat itself. So tangent at 3 pi fourths, okay, so that would be like, let's see here. You know, just, this is supposed to be quick graphs of tangent. So here's what you need to know. Tangent, it's down at negative 1, goes to the ground level at pi, and then it's up at a height of 1. And it keeps repeating itself over and over again. So what do I want to know about tangent? Well, I want to know that it has a period of pi, and it keeps repeating itself thusly throughout. It looks kind of like this here. But it would keep repeating itself over and over again every pi units on the x-axis, and it goes from negative 1 to 0 to 1 throughout its period there. So and that it has asymptotes at every pi halves plus some pi on top of that times, say, k, where maybe k is an integer, you know, basically any multiple of pi essentially added on to pi halves. So that is, if you go out pi units past every pi halves, you're going to land at another asymptote anyway. So these are the basic graphs of sine, cosine, and tangent. Put these on flashcards. Memorize them. Do not forget them. Know that sine, again, here we go. Sine starts on the ground, goes up, down, down, up. We just need to take its period and split it into fourths, and that's how it does it every time. You know, cosine, again, starts up in the air, goes down, down, up throughout its period. We split the period up into quarters, okay? So we drew out the period, split it in half, split those halves in half. And then same thing with tangent. We'll take its period of pi, split it up into fourths, and let it do its thing. Memorize it. Put it on flashcards, seriously, please.